Hi, my name is Maria Villagrana.
I'm Alejandra Lopez. I'm Miley Gonzalez.
And we're the dynamic trio from Arleta High School. As we know, bridges have been a staple in our society for as long as we can remember. For the main convenience of transportation of goods, people, and overall to just allow us to effectively commute better in our society. Moving on to how we actually designed our bridge, we took into consideration many of the past bridges from past competitions. We looked at the bridges we see like in our life, society, and we took our design once we finally decided that X's would be most effective and most durable for a bridge to be sustained. We took our design into the West Point Bridge software simulation, which allows us to actually create our design in the software, and it's basically a simulation of a truck driving over it, and it shows where the compression and tension would be placed when the load is actually placed onto the bridge. And once we were finally successful and the load was successful passing through the bridge, we took that design into AutoCAD, and AutoCAD basically allowed us to see the bridge in a better visual representation and how it would look more realistic in our life. Now Alejandra is going to talk about the bridge construction, and so.
As Maria mentioned, once we determined the actual design, we began the construction. The construction sequence consisted of selecting our popsicle sticks. This step, although tedious, is very essential and crucial because if we did use a broken, weak, or crooked stick, it could overall compromise the construction. Once we selected our sticks, we began to glue both the upper and lower beams in an up-down alternating pattern, gluing exactly 11 sticks together, approximately up to 43 inches. Once we created all 4 upper and lower beams, we began to glue the actual members. In this case, the members are the X's displayed here in its respective spot, all clipped down with binder clips on a wooden plank to ensure that it was straight. Once we completed the first side, we would flip it and then glue the rest of the members. Once we completed both the left and right truss, we doubled everything to create a second layer of durability. And once we doubled both left and right truss, we began to triple the upper and lower beams to again ensure that it was strong enough. Ultimately, we determined the roadways with the assistance of the wooden plank. Once we did that, we began to glue the actual roadways with the one popsicle yes, one popsicle no all the way down, leaving a 1/2 inch hole for the force. When the bridge is loaded, the load is distributed to the supports and foundations because of the force acting on it. In this case, the force acting on it is the weight pulling it downward, creating compression up here, distributing outwards, ultimately creating tension along the truss. Some issues that occurred when constructing our bridge as far as the actual construction would be our upper and lower beams curving upward, or just overall our structure being crooked. As far as some personal issues that we did have were our team members being absent, but of course with any problem there's always a solution. And some things we did to resolve these issues was leaving it clipped down on the wooden plank, as you can see there, I don't know if you can see, but with binder clips to ensure that it was straight. As far as the actual issue with our members, if one was absent, we would stay after school or come before school, or even during class, we would do the most that we could. Now Violet will be talking about what we learned aside from the actual construction.
Things that we learned while making the bridge was responsibility, time management, and that we were going to have a few errors while we were making our bridges, but it was okay because, as Alejandra was saying, we had trial bridges, and with those trial bridges, we were learning that what we can do better in our next bridge and what we would want our final bridge to look like. This has changed our point of view of what engineering is in many ways. We see engineering as a more complex thing. It's a very much planning and deciding what we're gonna do, and that is it's a whole process. Definitely like seeing it and doing what we had to do. I would want to work and be an engineer now, and this kind of helps me see what my options are. And this concludes our presentation.
Thank you.
Yes.